Factors in measuring the geoid model. Let's take a minute to demonstrate the factors in measuring the geoid model. How much should be hidden from our sight by the calculated convexity of a body of water?
The geoid model, or WGS84 mathematical construct, states the Earth is an oblate spheroid 24,900 miles or 40,075 kilometers in circumference at the equator, and 24,860 miles or 40,008 kilometers circumference over the poles. If this is accurate, then given these parameters, the surface of the body of water must have an average convexity roughly equal to 8 inches per mile squared in all directions. This means in 1 mile, the surface on average will be 8 inches lower compared to the starting point. But in 2 miles, the convex surface must be calculated as 8 inches times 2 miles squared, which is 8 times 4, or 32 inches. At 3 miles away, there must be a 72-inch drop, and in 10 miles, a drop of 66.6 feet, or 800 inches. In metric units, a 5-kilometer distance should create a 2-meter drop, and a 10-kilometer distance, a 7.84 meter drop. This calculation would give a result of 1,525 feet, or 465 meters, on the total distance of 48 miles, which is 77 kilometers, over Lake Balaton.
The polar and equatorial circumference differential is relatively insignificant to factor in, but FE-Corps did calculate the ellipsoid correction for each measurement. This correction value in the magnitude of 1/25th of an inch, or 1 millimeter, is well below the margin of error for the TLT measurement method. The WGS84 geoid is not a perfect ellipsoid geopotential surface, and it may have local anomalies. Deviation from the perfect ellipsoid surface is called geoid undulation. The WGS84 geoid undulation map shows these correction values, so this data can be compared with the laser and target positions. When we stand by a lake or the ocean in the curved surface model, the height of our eye level above the surface of the water determines just how far we can see before the convex shape of the water would begin hiding objects from our view. The point where our line of sight would be blocked by the water is called the horizon, so the distance to the horizon would be determined by the height of our eyes or camera above the surface of the water.
On February 22, 2018, at 10:44 p.m.,
on the first day, we had a successful observation, but we became aware of it only after analyzing the recorded footage. My camera at the garden of the hotel recorded the handheld blue laser pointer used by the observation team as they were giving targeting signals from the opposite shore 12 kilometers away.
The blue laser pointer was 1.5 meters, or 4.92 feet, above the surface of the water. Karen's camera was 1.6 meters, or 5.25 feet, above the surface of the water at a distance of 12 kilometers, or 7.46 miles. The 12-kilometer distance calculation based upon the WGS84 model results in a target hidden height of 4.56 meters, or 14.96 feet. The lake temperature was 2 degrees Celsius, and the air temperature above the lake was 3 degrees Celsius. The ambient conditions showed the refractive indexes were about the same at the two sides of the lake where the teams were positioned. The difference in temperature was marginal both vertically and between the two sides of the measurement. The difference in humidity and temperature between the height of the laser and the height of the camera was insignificant. FE-Corps concluded that the gradients above the lake did not cause any significant refraction of the laser beam. To reach the maximum precision, FE-Corps factored in all the possible corrections for the WGS84 geoid and calculated the mean sea level ellipsoid, the geoid undulation, and the refraction corrections for each measurement. The height of the laser pointer was 1.5 meters, and the observation position height was at 1.6 meters. The WGS-84 geoid map shows 0.129 meters geoid undulation at both sides of the measurement. That meant there is no significant difference in geoid undulation. The TLT measurement data shows that at least 2.96 meters of curvature was missing on the total distance of 12 kilometers on the surface of Lake Balaton. There is also a possibility of a local geopotential anomaly, but the WGS undulation map clearly shows last night of the team's scheduled stay at the lake, FE Corps observed both the blue and green lasers placed at Balaton Vilagos and seen from Siofok 12 kilometers away. Measurement 2. On February 26, 2018 at 8 o'clock p.m. The blue laser was placed on the salad at 2.2 meters or 7.2 feet above the surface of the lake at Balaton Vilagos. The source of the beam was seen from Siofok 12 kilometers or 7.46 miles away at 1.6 meters above the lake.
Okay, here it comes, here it comes, here it comes.
Here comes the blue. Oh!
I see it. That's a freaking laser pointer, guys.
The reason why I'm on my phone is to show everyone this. That was the 12 kilometers today. So yeah, this is worth everything to me. Yeah. So to us. Mm-hmm. Yes, to us. So I just want to add that I think it's been a brilliant working with these guys, and it's been bloody cold, hard work, and like Karen said, a lot harder than I imagined.
Two measurements performed at Lake Balaton showed that for the 12-kilometer distance, the lake surface did not conform to the WGS-84 geoid model. The laser height was 2.85 meters above the surface of the lake. This location was well known by Mike, who had been there many times over the years. The choice for the reference position was a small stand of trees about 25 meters tall on the opposite shore. Mike had often wondered how it was possible to see the trees over such a great distance. The team chose this location as the Target 1 reference position for calibrating the salad because Mike had been to the trees previously, so he knew the location had good access to the lake for an observation. This was FE Corps' first chance to use the new GPS TLT system, so in addition to attempting to measure the lake surface for geoid comparison, the team was also testing this new method. Measurement 3, Lake ISIL Target 1. On April 8, 2018 at 1 o'clock a.m., the blue laser was on the salad at 2.85 meters or 9.35 feet above the lake surface. It was seen at the Target 1 position 21.26 kilometers or 13.21 miles at a height of 1.2 meters or 3.94 feet above the lake surface. It took less than 60 seconds for them to see the source of the laser at the Target 1 location.
Can you guys see it?
Yeah, I see it. Yeah, it's there. Okay, yeah, we can see it really well there.
Can you see the reflection on the water?
I'm gonna zoom out.
Yes, we do. Yes, we do. Look at that.
Wow.
Oh, man, that is irrefutable.
Yeah.
Awesome.
Oh, I can watch this all day, you know?
This is awesome.
Yeah, this is really awesome.
Look at that reflection. That reflection absolutely caps it.
Yeah.
Yeah. That caps it. That annihilates any possibility of it being refracted, and that also annihilates any possibility of any convexity.
Yeah.
I mean, you cannot track it with being curved.
The 21.26 kilometer calculations based upon the WGS-84 geoid model resulted in a target hidden height for measurement 3 ISIL Lake, Target 1 location of 18.18 meters or 59.6 feet. The camera height was 1.2 meters. The WGS-84 geoid model differed by 16.98 meters in this measurement, which meant 93% of the target hidden height was visible. The lake temperature was 7.6 degrees Celsius or 45.7 degrees Fahrenheit, and the air temperature was 10.8 degrees Celsius or 46.4 degrees Fahrenheit above the lake. The ambient conditions showed the refractive indexes were about the same on both sides of the lake. TLT calculations factor in any variations in recorded data and geoid datum parameters of the WGS-84 mathematical construct. Both target and laser positions are at 0 meters mean sea level. The WGS-84 geoid undulation map shows a marginal 23 centimeters or 9 inches height difference at the two positions. Measurement 4. After the measurement at target 1, Mike and Patrick drove 30 minutes to the target 2 location. Target 2 was selected because it would be within 17.5 degrees panning limit of the salad. Since the salad had been calibrated at target 1, the automatic GPS system now required only a new coordinate to automatically target that position. This was the first field test of the new GPS TLT software, so it was an exciting moment. On April 8, 2018 at 3 o'clock a.m., the blue laser on the salad was 2.85 meters or 9.35 feet above the lake surface. It was seen at the target 2 position 28.68 kilometers or 17.82 miles away at a height of 0.85 meters or 2.79 feet above the lake surface.
Okay, check this out, brothers and sisters. 28 kilometers in your face.
Wow. Awesome. That is awesome.
My camera is 85 centimeters above sea level.
Look at that. That's amazing. You can see it reflecting off the lake water.
Yeah.
That's astounding.
That's the nail in the coffin.
Yes, it is.
Oh, this is so great, boss. It's really awesome.
The 28.68 kilometer calculations based upon the WGS-84 geoid model resulted in a target hidden height for measurement 4 ISIL Lake target 2 location of 40.21 meters or 131.9 feet. The WGS-84 mathematical construct differed by 39.36 meters in this measurement, which meant 98% of the target hidden height was visible. The team moved to the 40-kilometer location, or target 4. At 40 kilometers, finding the source of a laser beam with the naked eye is almost impossible, especially if there are other light sources on the horizon. A telescopic camera was the solution to distinguish the laser from the other lights. Measurement 6, Lake ISIL, target 4. On April 22, 2018, at 2:19 a.m., the blue laser was on the salad at a height of 2.92 meters or 9.58 feet above the lake surface. It was seen from the target 4 position 40.14 kilometers or 24.94 miles away at a height of 1.5 meters or 4.92 feet above the lake surface. The 40.14 kilometer calculations based upon the WGS-84 geoid model resulted in a target hidden height of 90.81 meters or 297.33 feet for measurement 6 Lake ISIL target 4 location. The WGS-84 mathematical construct differed by 89.31 meters in this measurement, which meant 98% of the target hidden height was visible.
Yesterday we had a little bit of bad luck because the beam of the light was not so good visible with the camera. We could definitely see it with the naked eye, but to catch it on camera it was really difficult. So we have adjusted some things for today and we are truly expecting better results.
Yeah, but the intensity is going down.
Yeah, that's a little way down.
Okay, just put it one step up, stand up. Okay, one more. Put the steps.
Wow!
Put the steps on.
I think I just caught that.
250,000. One more.
Almost see the scenes.
One more. Okay. Yeah, one more. That's
Maybe
it,
one
bro.
more. Maybe. Oh, yes,
Yeah,
I can
one
see
more,
it.
one more.
One more.
You got it?
I could tell. I was looking right at it. More down.
Down?
Yep.
It's going up.
Get one now. See what's up.
Yeah, just now. I think we're looking at it. Right, not right.
Yeah.
With the naked eye.
F.E. Core examined the effects of refraction through the gradients in the air by adjusting the beam vertically. It was concluded that with the present ambient conditions at measurement 6, the beam was refracted downward by a maximum of 0.064 millimeters.
We were shooting the laser 40 kilometers across the lake. We did find it on the target location, but it was already getting light, so the intensity of the beam was almost not visible anymore. And we had some issues with finding the right orientation of the beam itself. So now that we know where to actually point it, we're going to try it again today to get it on tape.
Measurement 7. In the evening of April 22nd, the team returned to the Target 4 location. They worked late into the night taking many pictures. Rick's camera was set to take one picture every 5 seconds.
So the source of light, whatever's going on top of the water, you're not going to be able to see it. There's too much humidity, the water's boiling, it's spraying.
Yeah, and it's windy on your side, right?
Oh, it's real windy on our side.
Yeah.
Okay, buddy.
Andre, can you see it then?
So, there we go.
Nothing at all?
I cannot take it off camera. There's just not enough light coming off from
First
it.
of all, there's too much light pollution coming at us too close. Then it'll knock that out.
Measurement 7, Lake Isel, Target 4. On April 22nd, 2018, at 11:20 p.m., the blue laser was on the salad at 2.92 meters, or 9.58 feet, above the lake surface. It was seen at the Target 4 position 40.14 kilometers, or 24.94 miles, away at a height of 1.5 meters, or 4.92 feet, above the lake surface. The parameters and outcome of measurement 7 was the same as the one from the previous night. The only difference was the maximum refraction of 0.133 millimeters caused by the slightly different ambient conditions. The observers should not have seen the laser at any height below 89.3 meters, or 293 feet, but the beam was recorded from a height of 1.5 meters, or 4.92 feet.
Stop. Okay. Bring it down now. The laser down.
Going down.
Zach, if you want to record some of this, you can. I didn't know you were doing.
I'm trying to record something. At least.
Okay, you still coming down?
Yep.
Okay, stop. Go back up a little bit.
Conclusions.
The results of the 7 TLT measurements indicate that these two lakes do not conform with the WGS-84 mathematical construct and that they lack the predicted convexity. The testing results agree with the analysis of error sources. In summary, the testing results of the lake surfaces were plus or minus 0.2 meters and the relative accuracy was within 1%. In conclusion, the TLT measurements met the accuracy of the experiment design requirements and provided a definite deliverable output.
The surfaces of Lake Balaton and Lake Isel do not conform with the predicted convex shape of the WGS-84 mathematical construct. Through analyzing error source models of TLT measurements and corrections for the geoid surfaces, we determined that the TLT measurement results conclusively prove our hypothesis of non-convex water surfaces.
Never in history have independent researchers been capable of falsifying these axioms by direct observation and measurement. F.E. Core has made new and meaningful discoveries with its very first project establishing an enormous amount of missing predicted convexity on both lakes. Thanks to the support of all FE Core subscribers and project participants, a great addition to the body of scientific knowledge has been made.
We welcome you to join FE Core by becoming a member and supporting our scientific endeavors, or even contribute in your field of expertise. You are invited to follow our team across the Earth as we continue to explore the true nature of our world.